So, hope that divine song has actually indeed blessed all of us. So, now I kindly request our respected HOD, Dr. Sunita KR, to address the participants and share a few words on this online faculty development program.
Okay. So, good afternoon to all. So, respected Chairman, Professor Ashok Jairam sir, and respected Principal Dr. J. Prakash sir, and dear faculty members, I, Dr. Sunita K.R., Professor and Head, Department of CSC, heartily welcome you all for the 5 days faculty development program on generative AI and agentic AI. So, just to highlight about our institute, so our institute BIT, Bangalore of Technology, was established during 1971 by Rajya Vakkarikara Sangha, and BIT is recognized by AICTE and accredited by NBA and NAC with A plus grade. The institute offers 13 UG, 5 PG, and 15 PhD programs. And our Department of Computer Science and Engineering was started in the year 1981, and we have MTech program as well as PhD programs. So the department has highly qualified nearly 34 faculty members with 11 doctoral degrees. And to highlight about the FTP program, the FTP aims to provide faculty members with an in-depth understanding of generative AI and agentic AI. And FTP coordinators, Professor Netravati B and Suma L, will brief day-wise schedule and share details of eminent speakers. I invite all faculty members to actively participate and gain insight into the emerging trends of AI and request to extend your cooperation for the smooth conduction of FTP. So thank you all. And I will, yes, Suma, you can continue the session.
Thank you, ma'am, for your encouraging words. Now, it is my privilege to introduce today's distinguished resource person, Mr. Naman Sinha. Mr. Naman Sinha, currently working as senior software engineer at Fractal. He is an Azure expert with rich experience in artificial intelligence, data engineering, and cloud solutions, having delivered impactful projects for global organizations. To highlight a few key projects, here we go with automated label inspection, which is an AI based OCR, object detection system to automate global label inspection for Philips. Azure Infrastructure Analytics, which is an award winning solution for Azure cost optimization using data lake and mediation architecture. Where the third key project may be a smart pipelines automation to create a optimized DevOps pipelines to reduce deployment times significantly, which is the next Microsoft Graph integration. So the integration of Microsoft Graph Tech Stack for Planner, To Do, Teams, and other O365 Dynamics using Graph Explorer for enterprise use. And the list actually goes on. Mr. Naman Sinha has been recognized with multiple awards as well, including the winner and second runner-up titles at the Philips Azure Data Lake Innovation Drive and the prestigious Star Award at Practical for Innovation. He has authored numerous technical articles, delivers impactful training sessions, and is currently writing book on Azure API management even. His remarkable contributions in AI and cloud computing make him an ideal resource person for our FDP on generative AI and agentic AI. I sincerely thank for Mr. Naman Sinha to accept our request and willing to just be part of this entire FTP. So finally, I actually sincerely thank my department for giving me this opportunity to extend a warm welcome to all the participants and our esteemed resource persons of this online FTP. So now I would actually invite Mr. Naman Sinha to take over the session, where he's actually glancing about the FDP structure and what all the requirements to gain the certificates, maybe with respect to the attendance or the quiz scores and all. So then we'll proceed with the formal content of the FDP. So Naman, sir, you could actually share your screen and start the session. Thank you all.
Sure. Thank you so much, ma'am, for the warm introduction. And hello, everyone, respected teachers, faculty members, and all the dignitaries. First of all, thank you so much to the management of BIT for holding this entire session. And apart from that, yeah, let me share my screen. Please let me know once my screen is visible. I request someone to confirm if my screen is visible.
Yes, sir. Yes, Naman, sir. It's visible.
Thank you so much, ma'am. So, welcome all once again. And as ma'am said, I've been like working for 5+ years in the industry and on various job profiles. So currently, I am a lead software engineer at Carl Zeiss and also the founder of SwipeGen, through which we are helping VIT with the entire FTP. So let's just get started. There are few things before we start. I would like to just give you a glimpse of them and also what you need to take care or what you need to keep in mind. So for each of the 5 sessions, we will have distinguished speakers. Let's say the first and fifth session would be held by me. The second and fourth one would be by a different industry expert, and the third one would be by someone else. However, what remains constant is that we start with some introduction to the topic, and then maybe we do some deep dive into some specific topics, which are like the key areas or like to the core of this entire faculty development program. Followed by that, we will have hands-on sessions every day. So for the hands-on sessions, I think it is the only expectation is that you have a good internet and you join with your laptop. Remaining things, I don't think there are any local installations needed in most of the cases. However, if there are any local installations needed, we will definitely let you know well in advance. Or if they are like very small 1 or 2 KB or MB files, you could do it dynamically on the runtime during the hands-on training as well. And then the fourth section would be kind of interesting. We will also be holding a quiz every day. The quiz will contain 20 questions and we will be having a leaderboard. So at the end of the fifth day, who will be the top 3 members in the leaderboard? They will get some free course vouchers from SwipeGen. This is only to keep you more and more interested and motivated towards learning, and also propagate evaluation based learning. So I think it's equally important that when you hear out so many different new topics from us, you can also assess yourself, and you could also come back with questions. So this is how we have structured the whole faculty development program. I think you already have the details of what would be done each day shared in the WhatsApp group. So without further ado, let's get started. And before I start, anyone has any questions? In case you do have, please feel free to use this chat window of your Microsoft Teams application. The moment you click on chat, you will have a text bar open here where you could just post your queries. While I'm not looking at this place at the moment, once I look back here, maybe during the break time or once I take some small pause, I will definitely be answering each and every query. So please feel free to post your queries, or else you could anytime unmute yourself and maybe ask for a specific question if you have at that moment. So I would appreciate more and more questions coming from your end, and that would make this a very effective session. So before we get started, anyone has any questions or queries or concerns?
Participants can answer. If you have any query, you can just get the doubt cleared.
Okay. So if not, probably let's start looking at the content. Probably then you will have more and more questions, and I would be happy to answer. So yeah, shall we get started, ma'am?
Yeah, sure. Naman.
Thank you.
You can start. Yeah.
So yeah, as you know, this would be a 3 hour session. So we've already got some 25 minutes done. So let's right jump in. So to start with, as I said, the agenda involves having an introduction to the artificial intelligence and machine learning ecosystem. Please know that this session is more of a foundation for you to know all the fundamentals quickly brushed up. Apart from that, in the deep dive section, we have GANs, etc., being discussed, which are like to some extent, core technical. Once we do those, we get into the hands-on mode wherein you just require your Gmail and nothing else for us to finish up your hands-on session. Uh, we request all of you to be signed in your browser with your Gmail. That is the only thing expected for the hands-on session. We will help you get a Google Colab uh, stuff done, and then from there on we will take it forward. And the last section would obviously be the quiz, followed by the feedback. So yeah, here we go. So let's start with the first part, which is introduction. So yeah, AI and ML, right? So the first question that I have for all of you is, before ChatGPT, I am sure you know this whole artificial intelligence buzz has been there for quite a while, like more than a decade or something. Probably post 2010, there have been like sufficient buzz around cloud computing, artificial intelligence, machine learning, etc. But can somebody tell me what changed after ChatGPT came in 2022 November? Like what changed that every other company wants to build either AI products or offer AI solutions or train their freshers on AI or open more AI jobs or even name their company, let's say something.ai. So I know there are people comparing it with the dot-com bubble, but I just want to understand if anyone has any ideas on what changed after ChatGPT came in. Anyone? Okay. I will keep this question. I will allow you to post your answers in the chat and then I will revisit this question later. Now, let's first understand the relation between data science, machine learning, AI, deep learning, data mining. I think there are a lot of terms which are used kind of in a very similar fashion, and not many people know the difference about it. So I just came up with this slide which can help you understand what is a subset of what, right? So, for example, the umbrella term for all of the things that you do in and around data is where you call it data science. Now, if you were somebody working in the IT industry, you would have data engineers, you would have data analysts, you would have machine learning engineers, you will have artificial intelligence engineers, you will have ML ops engineers, all of them as a part of your data science unit, right? So anything essentially which you are doing with data becomes, the umbrella term you could call is I'm doing something in data science. Now, what is artificial intelligence? Artificial intelligence, as you would discover eventually, is something which is a subset of data science, more focused on predictions and forecast, and also gaining more and more insights. So, to again club further, artificial intelligence as a term would include all your machine learning and deep learning engineers and your data analysts. Data engineers, however, for some reason would fall in the data science outside the AI, right? Now, let's dig one more level deeper. Now, what is machine learning? Machine learning is a very specific case of artificial intelligence where we mostly focus on textual information. So, all the predictions that we do, all the forecasts that we do, all the analysis that we do mostly revolve in and around textual information, right? That is when you are a part of the machine learning ecosystem. And the moment you start talking about deep learning, you are more moving towards images, speeches, audios, videos, you know, PDFs, and so many other non-binary content. So I hope this is clear so far. Deep learning involves text, anything other than text, which is as a data. Machine learning is focused on text. Artificial intelligence is a combination of machine learning, deep learning, and anything in general to do with forecasting and predictions, where you want to look into the future. And another unit of artificial intelligence is to automate tasks which humans can do, right? Then you have data science, and there's a term called data mining. Now, what is data mining? In data science in general, you approach a problem of data science with a focused output. But in data mining, what you intend to do is you want to extract something which is not known so far. That is exactly how you mine under the ground as well, right? So you want to discover some insights which your data could provide, maybe some correlation, some associativity between two data points which you want to understand but you are not sure of, right? So you want to discover more and more. That time you go for data mining instead of data science. Okay, so is this clear so far? Shall we go ahead? Now let's look at the difference between AI, ML, and DL. Now, since this is more of a revision and most of you would know it, so I would not invest much time here. AI is basically the engineering of making intelligent machines and programs, while machine learning is the ability to learn without being explicitly programmed. Now, here what becomes very critical is since ages, right? Probably more than 3 or 4 decades, we've been writing code in Fortran, COBOL, C, Java, and other programming languages. But let's say if you have written a small Java or C sharp or C++ function to calculate the sum of 10 numbers or maybe 100 numbers in an array, you cannot expect the product to be an output, right? This is where your core conventional programming differs from machine learning, wherein machine learning would help you not only calculate what is already supposed to be written. Apart from that, what it would also allow you to calculate is by giving you more and more recommendations that yes, from this array of 100 numbers, there could be other relations between the numbers which could be understood. You could also it could predict whether you would in the future require a product of those numbers and already give it for you. So anything where it is using its own intelligence, it becomes machine learning. And in deep learning, the core of deep learning falls in the deep neural network, which is also something I would explain in a very simplified manner today. So deep learning is also about hidden units, hidden layers, and neural networks, which we will see eventually. Now, why? Okay, before that, why do we need deep learning when machine learning is already there? I will explain that with a curve as well. So AI, yeah, this slide just defines that it's a popular branch of computer science that concerns with building intelligent, smart machines. And with rapid advancements in deep learning and machine learning, the tech industry is transforming radically, which we all know. Now let's come back to the question that I asked you. What changed after ChatGPT? Let me check if we have any answers in the chat. User interactions with AI components have increased. It made companies give more focus to users, personalized experiences with AI builds. Okay. Integrating AI with existing system for automation. User interactions. Okay. One thing I would definitely agree with what Dr. Karthik says is that user interactions have become a bit simplified, right? However, if you look at this slide, and thank you both of you for answering. Now, if you look at this slide, this will exactly explain you the past, the current, and the future of the AI industry. And that is why I call this the most significant slide for today. So what we've been doing since 2000 to 2015 or 20 is we were mostly in the narrow AI section. For example, now you wanted to search something in your mobile phone, but you do not want to type it, you've got speech to text. That was a specific problem that somebody solved, right? Now you wanted to predict how many fans Crompton as a company should manufacture for the next summer so that it does not run out of fans. This is again a very specific prediction based on a very specific industry use case. Similarly, somebody said, I want to filter out all these spam emails from my Gmail. That is again a narrow AI. So narrow AI is what we've been doing so far and is very extensively used till date, is where we specialize, we have specialized systems designed for specific tasks like voice assistants, etc. So wherever you were solving a very specific problem and you had a smart AI bot or an assistant to do this, you called it narrow AI. Now, exactly what changed after ChatGPT came into picture is general AI. Now, with 2022, we entered the general AI phase wherein ChatGPT as a tool could essentially do anything and everything for you. It can extract information from PDFs, it can generate new images, it can generate audios, it can generate videos for you, it can teach you, it can help you solve life problems, it can help you with revising your complete syllabus. So now it is no more a very specific tool. It has become a general tool. And that is why, with more and more people using it because of simplification, we have entered a general AI era wherein one single tool or application is able to perform or outperform humans in n number of ways, right? So with different kinds of use cases, we've entered general AI as a single tool. Now, what is still not there? It's super intelligent AI. This is the futuristic AI that companies have invested billions of dollars to build in, and they are currently trying to build it. We are not yet there. What is this? This is where one single tool beats humans in all the dimensions. For example, choosing what to eat, choosing when to sleep, sending office, doing the complete office work for them, knowing some mishap in advance. So basically, all the things which even humans would take more effort to do or cannot do, right? When you enter this kind of a tool in market, you call it super intelligent AI. So we have real world examples already for narrow AI, which is like chatbots, recommendation systems. We have some for general AI, for example, the ChatGPT, the DAL-E model, and then so many others, the Gemini. And then super intelligent AI is something which we are looking forward to build. And this slide would explain you the purpose, the examples, and the learning capability, etc. So I would request you to take a pause and then read out the slide so that you understand it better. And if you focus on the learning capability, so the narrow AI usually uses narrow data sets and limited to specific problems. However, general AI can learn and adapt like humans across various fields. This is exactly the difference between the conventional AI tools that we were already using. Like for example, if you hear your favorite music on Spotify or any other music channel, they used to give you recommendations already, right? Your Gmail already used to push emails in your spam. That was narrow AI, but ChatGPT can do both of them or anything like that, right? So it becomes general AI, and then super AI learns and improves autonomously, exceeding human learning speed, right? Similarly, for the type of AI model, you have fixed programming tailored models, and then this one is self-capable, and this one is, self-capable and in a more faster fashion, so on and so forth. So now that you know this, let's look at machine learning, right? So machine learning is a type of AI that enables machines to learn from data and deliver predictive models. So as I said, this is more about textual prediction, right? Unless we start dealing with anything which has more layers. The reason we get into deep learning is because we cannot our machine learning conventional algorithms cannot handle feature extraction from audios like voices, images, and then let's say videos wherein you have like audio and images combined. So such kind of things. That's where you require deep learning. So, as I already explained, the difference between traditional modeling and machine learning is that whatever you feed in terms of a handcrafted model, or this is what your basic C program is, or any program that you write, you feed in some data and your computer gives you result. But here, your model or your code learns from the data that you feed in and gives you unexpected results as well. For example, something which you have not trained your model for, your model could even answer you back. And that is where machine learning becomes different from traditional model, right? And then, yeah, some simple steps for machine learning, if you see. So you first gather the data. Now, when I say data, please don't understand data as Excel files, right? Your data could be lakhs of recordings which Google picks from your phones when you do a Google search. It is also data, right? Every YouTube video that you see is potentially a data, right? So any Excel sheet is obviously a data. Anything that you see, for an example, if I take you to a website like, let's say, Google Colab. Now, every small or big thing that you see in terms of these bullet points or in terms of these icons, these images, these links, everything is a potential data. So depending on what output you want, you can gather your data and then you prepare that data. Now, why is preparation of data needed? That is because you just assume a project like sentiment analysis, right? So when you do a sentiment analysis, you would require, let's say, collection of data from various sources. The best example I can give you is, assume you are a founder of a company like Philips. Now, Philips sells a lot of digital electronic items like, let's say, trimmers. Suppose you rolled out a trimmer category in the market, and after 6 months, you want to understand what was the sentiment about that specific trimmer from people. Now, what would be the approach that you will take? You will send a feedback link to your customers saying, please give your feedback. And trust me, 90% of the times customers don't feel the feedback. So then can someone think, what else can you do? How do you get feedback on a product? How do you calculate data? Anyone? How can you actually collect the data about a specific product? This is where web scraping comes into play. So what is scraping is basically wherein people go and talk on Amazon and Twitter and WhatsApp about a product. So you may not give a feedback there, but you may write on Twitter, hashtag Philips, this trimmer is very bad. Or I did not like this trimmer because of so and so reason. Now, what companies do is they scrape all of the data where you have hashtag Philips and hashtag that model type, and then they hire a data engineer. What does a data engineer do? His whole job is to take all the spelling mistakes that you have done, etc., and all the random content that you've put on social media, etc., to scrape that and put it into a large SQL table or a large SQL schema. Now, at college level, we deal with, like, let's say, 5, 6 tables in a schema, like all the database management system that we built. But in the industry, one single, let's say, schema will have, more than 5,000 tables. And in those 5,000 tables, each table will have more than 1 trillion records or 1 trillion rows. That's the amount of data that one extracts from the web using a data engineer's capability and converted them into tables. Then the data engineer's part is done, and then you go to choosing a model for your machine learning. For choosing a model, there's a lot of trial and error. There's a lot of wisdom involved on what kind of prediction you want. So accordingly, you apply. I will also give you in the next few slides a list of tables, a list of machine learning algorithms as well. So once you've chosen your model, you train, you evaluate by taking a train and test set, and then you do a hyperparameter tuning. Now, what is, yeah, sorry, someone has a question. Okay. Now, what is hyperparameter tuning? When I talk about convolutional neural networks, I will explain you and show you exactly what is hyperparameter tuning. Okay. And the last one is you eventually, make predictions. So now let's quickly understand what is supervised, unsupervised, and reinforcement. I know most of you may know it, but for those of you who are still not comfortable in understanding when an algorithm is supervised versus an unsupervised, let's just discuss about it. So a supervised learning is used to train machines using labeled data. So a simple use case for supervised learning is wherein you want your model to predict whether the object present in the image is a cat or not. Now, what becomes very important here is that you want to predict cat. So you are labeling your data set based on cat as the output. Wherever the output variable is known, it becomes supervised learning. Whenever your model predicts cat as a leopard or maybe a cheetah, what you do? You reconnect. That means you are training your child or your model, right, in a supervised manner, wherein let's say your child is again committing some mistake, you first ask him to correct it, or maybe if he's walking in a different direction, you just change the direction. This is where supervised learning comes into play. Now, what is unsupervised? In unsupervised, the output is not known and it uses unlabeled data to train machines. A simple use case would be, let's say you pick any random image of a traffic. For example, let me say pretty relatable. Now, how do you identify from this image which one is a car, which one is a bike, and which one is a bus, or which one is an auto as well? So you've got 2, 3, 4, and 8 wheelers already here in this specific image. When you take lots and lots of images like this and start feeding it into a unsupervised learning model and let the model classify it differently. For an example, these objects look alike, so we categorize it separately. These two look alike, so we categorize them separately. When you do something like this, wherein your model does not know what to call, but it just segregates it differently by creating clusters, you call it the unsupervised learning approach, wherein what you do, the model segregates that all these things look alike. So I have segregated it. Now you want to call it bus, you call it bus. You want to call it car, you call it car. So labeling is in your hand, but then segregation, clustering, churning, all of this happens at the algorithm level. Then it becomes unsupervised learning. And the last one, reinforcement learning. Now, what is reinforcement learning? A reinforcement learning uses an agent and an environment to produce actions and rewards. Now, this is exactly how humans learn, right? So, for an example, when you do not want your child to actually touch a switchboard with wet hands, there are different approaches to it. One, you go ahead with a supervised learning and you say, hey, don't touch it. And it doesn't touch. He doesn't touch. Well, this is peace. Using a supervised mechanism, somebody learns. But then you cannot apply unsupervised learning here because you cannot allow the model or your child, let's say, for example, to judge whether to touch or not, because it's a little sensitive issue. Then you come to reinforcement learning, wherein if he actually touches, you probably scold him, or let's say you allow him to get some current or whatever, any punishment for a wrong move, and a chocolate when he actually does not touch after listening to you. So whether it's a punishment or a reward that you do for your model or your application to learn, that is where reinforcement learning comes in, wherein you act as an agent and you give an environment to your data set for it to do some actions and then give rewards if yes and give punishments if no. For an example, making a prediction for square shape out of 10 different kinds of shapes in the dataset. For example, you feed in some triangle images, you feed in some, let's say, square images, some rhombus images. In unsupervised learning, you have to classify all, but in reinforcement learning, you know the objective. The objective is to predict which shape is a square. So is this clear so far, supervised, unsupervised, and reinforcement? And I will explain you with some applications. But so far, any questions from anyone? Okay, if not, let's just get back and see the types of problems which supervised, unsupervised, and reinforcement learning solve. As I said, wherever you have regular predictions, right, your classification models, your regression models, etc., it becomes supervised learning, wherein you are just trying to do some forecast and decide on a yes or a no. So, but in unsupervised learning, you mostly do clustering and association. Another example of this would be, for an example, if you open your Amazon and you try to order a shoes, right? Probably, if you scroll down, you would see a section saying customers who bought this also bought something else. Can you imagine what that something else would be? Common sense. It can be socks, it can be a shoe shiner, it can be a shoe polish, right? It could be an height enhancer, it could be anything related to foot, right? Your footwear. So while as a human you could do this, but probably what you could not do is something at a very bigger scale. For example, you as an algorithm would or you as a person would not know the associativity into Chinese products or into American products because you are outside that ecosystem. So for machines to find out and do associative analysis of two products so that companies can cross sell them, you have unsupervised learning being applied. So they cluster bread, eggs, and let's say milk together. They cluster all these shoe things together. They cluster, let's say, tie, bow, and shirts together. So something like this automatically using an algorithm so that they can sell you something which you were not supposed to buy, right? So you go for shoes, but you end up buying three, four additional shoe related accessories and come back. This is where unsupervised learning comes into play. And reinforcement learning, as I said, is reward based, mostly used for gamification, as we will see in the next slide, the applications, right? So supervised learning, you see all the weather predictions. Again, please notice weather prediction involves textual information. Sales forecast, which how many shoes to sell next year, how many shoes to manufacture next year, how would my sales be 5 years down the line. All of this would be textual information. Stock price analysis, this also would be a textual analysis, right? Unsupervised learning, you see customer segmentation, as I gave you an example, and also the churn analysis of identifying the different types of customers. I think in the banking and insurance domain, this becomes really critical, wherein they want to figure out some people who are not eligible for loan, somebody who is eligible for loan, but there's a risk of repaying it back, some people who have a good amount of loan already, but they could still repay, some people with a very bad CIBIL score, but they could repay or they could not repay, somebody who has a very good CIBIL score, also has sufficient corpus and can repay and is eligible for loan. So these different categories of analysis, which we call churn analysis, which happens in specific industries, the companies create different strategies for different kinds of customers, right? So all of this is unsupervised learning examples, and for reinforcement learning is like exactly how you solve a maze, right? So if I could show you, let's say, I am sure you would have seen this. Yeah, something like this. Now, there are chances there might be two or more solutions to solving this maze, or probably this a more complicated one. Now, which would be the fastest, right? Let your model automatically apply reinforcement algorithms so that each time it encounters a hindrance, it gets a punishment, and each time it gets a success or a go through, it gets a reward. Eventually, where the reward points are the maximum, would probably be an indicator that your model found the fastest solution, right? So this is an example of reinforcement learning, and it is also helpful in training robots and building games, right? So because even in robots, you see, it's very important for your robot to actually learn that it need not, let's say, mop a floor which is not wet, right? For example, it's a waste effort which humans understand, but probably your robot would not, right? So for such kind of things, you have different use cases. Yeah, this is like one master slide for you to quickly remember and identify which kind of algorithm falls in which category, right? For example, let's say the regression, your linear polynomial regression, decision tree, random forest, KNNs, etc. They are all supervised algorithms, unless you enter k-means clustering, and where you are actually doing a lot of classification, like let's say PCA or a priori and FP growth, then only then it would be classified as unsupervised learning. And then you have some reinforcement learnings, which we will eventually see. So yeah, applications of machine learning, I think they are pretty straightforward. You have like diagnostics in medical science, using biotechnology these days. There's a lot of work going on wherein um, people want to calculate. For example, the best example was, let's say, COVID, right? So any vaccine or anything that is being prepared at the moment, there can be numerous side effects of it, and there could be numerous ways where it could affect a person's body. Now, using biotechnology and neural networks, if you apply these two concepts together and you have a very fast computer which could make the predictions of all the false or dangerous cases already within no time, it would be really fast to test the new vaccines that are being developed, right? This is one example, I would say, of medical diagnosis, right? And by the way, for all of this, what becomes really critical is quantum computing, right? So wherein we have qubits, etc. I have already written an article about quantum computing. I can ping that in the chat later. You can read through it to understand like how quantum computers work. It would be like a very simple, simplified article you could read through. Then you have, let's say, stock market trading, online fraud detections. You go on and on. Most of them are applications of machine learning these days. They could be of different types of machine learning. For example, somebody could be supervised, something could be unsupervised, something could be deep learning, could be something could be, let's say, a combination of custom and computer vision like self-driving cars. So categories might vary, but they eventually are all, applications of machine learning. So there are a lot of use cases. For example, when you talk about traffic prediction, I would recommend all of you to maybe read a case study about Singapore's traffic prediction mechanism on how they were able to streamline their traffic, almost a decade back. And the same model is something which is supposed to be applied in Bangalore as well. So yeah, similarly, product recommendations, Amazon already uses it. Speech, you do it on a daily basis by even typing your chats in WhatsApp these days. Image recognition, I think for waste segregation, it's a very wide use case. And also the best example is your face APIs these days in your mobile phones, right? So on and so forth. Gmail already uses email spam and malware filtering. Virtual personal assistant is mostly used by HRs in different organizations to automate their tasks. Online fraud detection is more about banking, insurance, and even cybersecurity things. So on and so forth. Then there are some challenges. Now, before I go there, I would like to take a pause and request any questions if anyone has. I would appreciate making it more interactive.
It is clear. No questions. You can carry on.
Thank you, sir. Okay, so let's now get into some challenges or limitations of machine learning. Now, please understand it is still machine, right? So error is always a probability. And while you see a lot of heavy advantages like you can know trends, you can know patterns, no humans needed, continuously it learns on its own. The disadvantages are high error susceptibility. Now, let me give you an example. I think you would have seen some gigantic structures like, let me show it to you. So something like an oil field set up in Middle East, right? Now let me show you some images. Now these are very complex structures, okay? And probably a better example would be, yes, something like this. Now you see these pipelines, right? Now all the oil mining or oil extraction that keeps happening, these all chambers are hyper connected with multiple pipelines. And at this point, they all work on, Bernoulli's and all those pressure principles. Anything goes wrong in terms of pressure in one of the pipelines could immediately cause an explosion, right? So far the technology that is used to regulate these pressure differences and act accordingly is IoT, right? Which is Internet of Things. So wherein they have sensors to detect the pressure and automatically the valves get opened or closed, etc. There's some manual, let's say, activity also being done for very hypersensitive things where error cannot be dared. But in some cases, you use IoT as well here. Now we are slowly getting into something more advanced than IoT and cloud computing. So we are getting into edge computing now, wherein we want to leverage the speed of 5G to quickly transmit even faster changes of all of these information to the cloud servers so that we can act even more fast and avoid any mishaps. But no matter how smart algorithm you deploy, the challenge still remains the same, that it is still susceptible to some error, right? So we are not yet at a point wherein we can completely rely on machine learning algorithms. So we always have, if you see these images, we always have internal checkpoints where manual interventions take priority over machine related decisions, right? So this is one disadvantage. Now, using edge computing, we are trying to solve it, but we are not yet there. Let's say data acquisition. Now, everybody knows about Facebook, everybody has an account. If you just Google the number of lawsuits which are filed against Facebook, you will find at least 10 lawsuits in every country across the world where Facebook is running into privacy concerns, right? So the problem is, how do you obtain data from people to learn? While there's so much of free data available because you already have ChatGPT kind of things, but the moment you stop the supply of data, right? If there is one final judgment in any of the countries to stop getting the data, and which is very, let's say, a very sensitive issue in West Europe or like in Europe in general, then a lot of these digital infrastructure could go down, right? Similarly, interpretation results are not always good. As you know, there is always some 5 or 10% of accuracy issues, and then time and resources, right? So you require heavy amount of resources to run all of this. Now, I would like to call out one very important thing when we talk about machine learning and all the AI stuff, which is this. I purposefully opened this for you. This is the Azure portal. Now, what is Azure in general? I think most of you would know. If you just Google top 3 cloud providers, you will see Azure probably on the second and AWS on the first, right? Look at this. So with Azure, AWS, GCP kind of tools in the market, what is very important is you cannot imagine artificial intelligence or agentic AI, generative AI, machine learning, anything without cloud. So please know one fundamental thing which is acting as the backbone of this entire industry is cloud. And the second big thing is internet. So please know that these two things are vital for all of the AI ecosystem. So anywhere you see cloud computing resources become a problem or internet becomes a problem, everything goes down. Now I would like to take you one more level back and understand, even if you have cloud and internet, there is still one thing because of which nothing would work. For that, I would like to understand from you. Look at this image. This is the image of the Azure data centers, or probably let me open the official Microsoft website for this. They will give you a map, global map of the data centers. What are data centers? They are nothing but large computers kept in specific places, and you access the computing power of those computers using internet. Now, look at this. This is like, let's say, in the entire universe or or like on this earth where all Azure data centers are placed, right? This is the thing. Now, can somebody tell me, this is North America, South America, Africa, Europe, Asia, and all. Can somebody think and tell me here why there are very less data centers in Africa and South America? and why there are so many data centers in North America and Europe, and now in Asia also, East Asia and Middle East also. Why Africa and South America have very less data centers? Can someone think? Any guesses maybe? Why these two continents have very less data centers?
Maybe the labors that are available there, as well as the availability of resources like power or the internet or all the other benefits.
Exactly, sir. You are correct. This is fundamentally about electricity or power. So, in a country like India, where you barely spend more than 2,000 rupees per month to get, abundant of electricity, 50% of the household incomes of people in Africa and South America, they go only in buying kerosene for them to get electricity, right? So a lot of poor countries here in both these continents, there is no abundant electricity. And you cannot imagine running your computer fundamentally without electricity or battery. So the biggest problem is if Microsoft as a company creates more data centers here, then the operational cost for them to run that data center 24 by 7 with 100% service level agreement is very high. That is why they choose to cater all the population here from these nearby data centers, but do not put anything here. So you see something here, that is because South Africa is relatively stronger. You see something here because this is Brazil. Sorry, this is some different country in Africa. Here you see this is Chile, this is Argentina, and then this is Brazil. Other than that, all the poor countries, there is no. So please know three fundamental things for all of your digital ecosystem. One is electricity, second is cloud computing or cloud and resources, and third thing is internet. Now let's come back to our discussion. I just wanted to show this to you, and it's kind of a very fancy website from Microsoft. So you could actually go inside their data centers, like taking a tour. So I would not open that in the interest of time, but I would request you to just go and play around with it. I think you like knowing how things work. So yeah, let me just get back. We are done with the challenges in machine learning. So now let's look at a more specific case of machine learning, which is deep learning, right? So yeah, we'll have a break at maybe 3:30 and then we would resume. So yeah, in terms of deep learning is a subfield of machine learning that is concerned with algorithms inspired by brain's structure. So without going through much of text and all, I can easily explain you what is deep learning. Uh, Exactly. If you remember this term, you would easily know what is deep learning. Deep learning is mostly about feature extraction. Now, what is a feature? What can you call a feature? Right? For example, if I search for an image like this, right? Now, suppose you want to train on the image and identify whether any image, this image contains a tiger, right? Now, carefully identify that one thing is the color, right? If you just start noting down what are the different things, right? What are the different things, you would realize that one thing is the color of the object. One thing is the background color. Next thing is the pixel position, right? Pixel position, I will explain you when I teach convolutional neural networks. Then the next thing is the shape, the edges location, right? So where are the edges? Like what distinguishes this snowdrop from this place, right? Similarly, after edges locations, you have, let's say, size, the proportion, right? The proportion of object in the image, right? So on and so forth. You will eventually realize that there are so many features that need to be extracted about a tiger. Let's say again, eyes position or like object position relative to the overall object, right? This is also one. So you will know that there are so many things to be extracted. Then eventually you could come up with something like a prediction algorithm. For all of these feature extraction, your machine learning algorithm would not suffice because you require hidden layers. So extraction of features happens layer by layer. And wherever you see more layers coming in, please identify it is deep learning, right? So you have an input, it extracts features, classifies, and then says car or not car, right? So I will explain you in a while. Please know that the process of deep learning is, a little more simple, I would say, because if you hear what we say is, if you get the problem, your 50% of the job is done. So understand the problem, identify the data, select the right algorithm. Now, one difference between machine learning and deep learning is machine learning problems can be solved by multiple algorithms, and also there can be multiple algorithms which can fit in a specific machine learning use case. But in deep learning, you will mostly have specific algorithms for specific problem types. Okay. So yeah, this is one thing you should know about selecting deep learning algorithms. Like maybe in machine learning, you try one algorithm, it doesn't work, you go to next, and like that you can go to 10. But in deep learning, this iteration is mostly two or three, not more than that. So you mostly have to identify it properly, and there are a handful of solution available in terms of algorithms. Then you train the model and then test that. This is like a very generic thing. Now let's look at supervised and unsupervised, deep learning neural networks. So you have ANNs and CNNs and also RNNs, right? So recurrent neural network is like a very specific case of convolutional neural network, wherein you have a fully connected neural network being translated into recurrent neural network. So once I explain neural network, I will explain you what is recurrent and then convolutional and all. But for now, just know that, yeah, uh, deep learning is an extension of some of your machine learning algorithms like regression and classification, but mostly on vision and, let's say, even for time series analysis, to identify more patterns you can use on the like deep learning algorithms in terms of supervised deep learning. But in most cases, your solutions would remain around audios, videos, and images. Okay. So yeah, there is one thing which you see about unsupervised called autoencoders, which would be in the next session, probably tomorrow. So there you could understand more details. So I would not go there, but yeah, let's say image recognition, NLP. Now, NLP, natural language processing, what would be an example? Now, let's say 3 decades ago or 4 decades ago, when all of the banking infrastructure in any country was handwritten, right? When banks started digitizing it, there could be multiple ways. One way of it would be to ask a manual, like a bank person, to manually sit and read from a paper and enter everything into the database, right? This would be one way. But can you think of a smarter solution on how to digitize a local paper? Like suppose I have got this piece of paper up here, and if I really want get this to get in the computer, I think there are two ways. One way is I start opening my notepad and then I type, let's say A, then B, then C. Or probably the other way would be, can someone think of the other way of digitizing this? Anyone?
OCR.
Exactly, OCR, right? So what becomes important here is I take a picture of this sheet of paper from my phone, but the model, the OCR, should be smart enough to understand the crap that I've written, right? Because my handwriting or somebody else's handwriting might not always be accurate. It may contain spelling mistakes. It may contain, let's say there are people who write F very differently. Like some people write F in a different way, somebody, and then there is small, there is, capital, and then you have something like, let's say, cursive writings as well. And then region wise also the characters change. So while OCR is like very easy to say, but what becomes like really difficult here is on how do you type. things, right? For example, just to give you an example, some people write F like this, some people write like this, right? Similarly, some people write A like this, some people write it like this. So things change. Some people's capital A looks like this. You will have some extra lines. Some people will write it very accurately like this. Some people will do it like this. So there are different possibilities even for a small alphabet, right? So for all of this, deep learning is very, very important because it gives you more and more information or data sets for you to make the right predictions, which is again not very easy to do as a part of machine learning. So this is where your NLP or natural language processing comes into play. Similarly, you have drug discovery and all of these other kinds of things as an application of deep learning. Okay. Now, why is deep learning important? Right? I earlier discussed and tried to tell you a case wherein, let's say, if we already have algorithms of machine learning performing well, what change does deep learning make? So look at this performance versus data graph. So first understand the dimensions. This one, as it increases, means the size of your data is increasing. And as you go up, the performance of your model is increasing, right? So with increase, how do you interpret this graph? With increase in data, while the performance of other algorithms mostly becomes stagnant, deep learning outperforms by enhancements in performance with increase in data size. So this is where you know, okay, if you're running a machine learning algorithm with 1 trillion records in a data set, you get an accuracy of 95%. There are high chances, maybe with 2%, with let's say 2 trillion records, you might get 96%, right? So the rate of change in performance with increase in data size is relatively more stagnant and not that steep in a regular machine learning algorithm. But in a deep learning algorithm, the moment you double the data set, your accuracy would immediately jump to, let's say, 99%, right? So that is because increasing the data volumes would give more and more dimensions to your deep learning algorithms to identify more and more features. And then applying unsupervised learning concepts, it does an associative feature analysis as well, right? So because of that, deep learning outperforms in most of the cases. And you look at this data also, right? The data is here, images, videos, speeches, and all. So with more volumes, this becomes very accurate. And why this also happens, in textual information, you usually don't have diversity, right? But in deep learning, or let's say in audios, right? Now I'm speaking something, probably if somebody plays a music in the background, the recording would be very different, right? Or let's say you are trying to build a speech to text system and you record your complete train set in a quiet room, and then you suddenly go out and then you start speaking in crowd. It won't work, right? So with so much of diversity, so much of accent difference, and so many other things, deep learning is very critical, right, for such use cases. But then, yeah, there are limitations of deep learning. As I said, it requires very large amount of data, and this sometimes slows down the learning process as well. Apart from that, the interpretability. Why this matters? This matters because as your data volume grows, the number of dimensions also grow. And the number of dimensions can be interpreted relatively easier by deep learning algorithms, but not by humans, right? So ultimately, what makes more difficult here is that when you add more dimensions, you tend to lose their weightage, right? Like which one is more important, right? For example, suppose there's a struggling cricketer and somebody goes for a selection, right? Now somebody looks at his data and says, okay, this person has scored, let's say, 500 runs in 5 matches and taken 7 wickets. Now, you will have to take a call as a selector whether this person classifies into a batsman or a bowler, depending on certain thresholds that you would place. Now, if he's taking 50 wickets in 5 matches, or let's say, sorry, that's very impractical. Maybe let's say 25 wickets in 5 matches, and then he also scores very high runs. A model like this would get confused. And then, while machine learning gets confused, deep learning models would apply even more important concepts there of going to average, going to the strike rate, going to the runs conceded, and so many other aspects, and then come up with a decision, right? So there are some challenges in deep learning as well. Now, before I go into deep dive, I think maybe we should take a 10 minutes break. Now, feel free to ask any questions that you have. Then we would mostly get into two topics, and then we would be done. One is the convolutional neural network, and the other one would be the GANs. Now, any questions so far? Is the session useful? Am I too fast or am I too slow? Any feedback so far? Thank you. Any questions? You can always reach out in the next 5 or 7 minutes. We will start maybe at 3:28. So may I request your attention back? We will resume in next 1 minute. If then anyone has any other questions apart from the topic, also, we will share a feedback form towards the end, and you can just write your comments there if you have any other queries, etc. I will also be there on the last day of the training as well on Saturday. So then we will conclude. And just to remind, like there will be a quiz in the end as well. So yeah, I mean, based on whatever you've heard, I think it should be easy for you to attempt that quiz. And towards the end of the 5th day, we have some vouchers, some free course vouchers from SwipeGen. Okay, so let's get started then again. Now we are at part 2. So neural networks, right? I think, yeah, it's not just like from the faculty member side, but also from the student side. I think it when we talk about neural networks, we just see about those mathematical calculations and all those things. But I think what lies behind is actually something really simple, and it's basically fundamental mathematics that's at play. So let's just understand what is neural network, or your convolutional neural networks, etc. So I will explain you what is a neural network fundamentally, and then you can obviously take it forward from there. So what do you interpret from this image first? What you interpret is, I hope I am audible.
Yeah, you're audible.
Okay. So you see some some input. This input can be a txt or any other format. Then you see this let's say purple section here, which is the input. Okay. You see some red sections, which is the output. In the middle, you see something like a very hyper connected thing, like each let's say circle is connected to every other circle in the next layer. Consider these as layers. Okay. Now, well, what are these layers? So what I will do now is I will pick up a problem statement, and using that problem statement, let's apply neural networks to it and then try to figure out how to solve it. Okay. So the problem statement here is that we want to predict whether a given shape is circle or not. Okay. That is our problem statement. Now, what are these circles that you saw? These circles are nothing but neurons. Okay. This is exactly how your brains work. For an example, if I touch this keyboard, I get a sensation. I touch some plastic material, and that sensation happens in one of the neurons. But then they are all hyper connected, right? My sense of touch is connected to some specific neuron, and that specific neuron is in turn connected to a different neuron, which makes me act about clicking whether a space bar or a G or a P or whatever on the keypad, right? So we have a connected web of neurons in our brain, and the same thing we are seeing here now. We have seen some neurons here. Now, what is the first step that you do is you take the circle here, which you wanted to check whether it is a circle or not. Take that image, break it down into a grid of 28 by 28. Suppose this is 28 by 28 pixels. So 28 by 28, let's say centimeters or whatever your measuring unit is, and you break it down into 784 pixels. That is the first thing that you do. Okay. Now, each pixel, for example, this black pixel, right? This one. This is one pixel. This is another pixel. Like that, there is 1, 2, 3, So on and so forth, 28 by 28 different pixels are there here. Now, what we do next is, let's see. For each of the pixels, we start feeding them right from X1 to X784. What are these X1 to X784s? These are neurons. So each pixel from your input goes and gets fed into the input layer in every specific neuron. Getting it? The first one goes there, the second one goes there. Likewise, probably the third one goes there. And then the last one goes here. So far clear? We are just breaking down the image into pixels, and for each pixel, we are feeding that as an input to the input layer of our neural network. Okay, so this is the input layer of our neural network, and each pixel goes as an input. Simple. What are channels, by the way? Channels are nothing but the edges using which input layer is connected to the next layer in the neural network. We will drill down in detail. Now let's see. What is this? This is the input layer. This is hidden layer 1, hidden layer 2. Like that, there can be hundreds of hidden layers followed by an output layer in the end. Okay. Now, what are we doing here is each input value is supposed to be fed to the next hidden layer, but using some equation. What is this equation? This equation is nothing but activation function. Okay, so basically, what is an activation function? An activation function is some, like, let's say, some mathematical equation which is doing what? Taking the value of the input, multiplying it to 0.8. What is 0.8? 0.8 is nothing but the weight. So take every input value from the input layer, multiply it with the weight, and then send it to the next layer of the input layer, but with a condition that there is something called as bias. Okay, B1, B2 are individual biases of every neuron. So every neuron has a bias. In this one, if you carefully observe, there are two input incoming things coming in. Like, maybe let me discard this and show you again. So here, if you see, there are just two inputs coming in. One is this one and one is this one. That is why to X1 and X3. One is coming from X3, one is coming from X1. So X1 into 0.8 goes here. X3 into 0.1 goes here. The two are added as a part of this bracket. And then ultimately what is happening? Ultimately, there is a bias which is added. And what is bias? Bias is a property of the neuron itself. This what is happening right now is called feed forward propagation. Wherein, what are you doing? For each value of the input layer, you are multiplying the weight and adding the bias to it. And then using an activation function, you are deciding whether this neuron is supposed to be activated or not. Now, why activated or not, I will explain you in the next slide. See here, you have something called as the activation function. Okay, now this activation function, what is the role of this activation function? There are some examples of activation functions. Probably let me make it a little bigger so you can see. There is an activation function called ReLU. Then there's an activation function called sigmoid. Likewise, there are many activation functions which help a neuron. Okay, all these boxes are neuron, which help a neuron decide whether to activate this and take or consider this value to predict the output or not. For some reason in this image, if you see, all the neurons which have become yellow from a specific input layer or hidden layer 1, only these are being activated. Now, if you carefully observe what happened, B1 got activated, B3 got activated, B4 got activated, B6 got activated, and B7 got activated. But B5, right? Two of the neurons did not get activated based on whose decision? B2 and B5 were ignored based on the activation function's decision. Okay. So then you do the same activity for the next layer. Then you do the same activity for the next layer. And ultimately what you realize is that the output is wrong. It predicted a square instead of a circle. This was a circle, but it predicted a square. So your output was wrong. Okay. But so far what you have learned is forward propagation, or sometimes also called feed forward network. So you are taking input from previous layer, multiplying weights, adding biases to it, and then feeding it into the neuron of the next layer. Based on the bias and weight, some activation function threshold is calculated, and it is decided whether to activate that neuron or not. If you do this activity for till the end, you get to some final version. Now, the output is wrong. Now, what do you do? And first of all, as a human, you can say this output is wrong. But how does your algorithm know that this output is wrong? Can you think? Like you saw that the prediction was 0. Was a square with 0.5 probability, but how can the model know that this is wrong? This is where you should know that this neural network is in training phase right now. And when something is in training phase, you know the output, right? So the next slide will show you that the actual output was supposed to be 0, 1, or 0, but here it gave minus 0.2, plus 0.4, and 0.2, right? Uh, Maybe can one of the members who is on unmute can go on mute, please? We hear some noise. Maybe Manjushri ma'am, could you go on mute? Okay, we don't hear a noise at least. So yeah, now so far what you should know is after the end of feed forward propagation, what happens is your model is compared with the actual output, and then you realize that the prediction is wrong. Then you do a back propagation. Now, what exactly is happening at the back propagation? What happens at the back propagation is you readjust the weights. Maybe here, 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 wherever possible. Go back, change the weight. Let's say from 0.3, make it 0.2, and then recalculate and see whether the model is correct or predicting correct or not. Similarly, do this change only here, or do this change 2 times, 3 times, and then compare. This is exactly what in the textbooks and all they will call as regularization. Now, what is regularization as a topic in the textbook or anywhere you see? Regularization is something that we do only to make sure that the model does not overfit, right? Model does not overfit basically means that it is predicting something which it should not predict. Means it has learned something wrong. To make sure whatever wrong it has learned, to make it unlearn, you readjust the weights. And if you remember in one of the slides earlier, I talked about a process called hyperparameter tuning in the step of machine learning. Somewhere I spoke about hyperparameter tuning. Point number 6. This is exactly what is hyperparameter tuning. To explain again what is hyperparameter tuning is, the parameters which are in your control, only those you can tune. You cannot change the inputs, right? What you can change? You can only change the number of neurons, the number of hidden layers in every neuron, in every neural network. So hidden layers or number of layers, number of neurons, when you start manipulating these things, maybe add one more layer, etc. then that is called hyperparameter tuning. Is this clear? Am I making sense? Like, you have any questions? Now you understand like what is hyperparameter tuning. Anything which is in your control and you can change. See, data you can't change, output also you can't change. What can you change? Adding more layers, adding more neurons, readjusting weights. Even then, please remember, weights and biases, they are not in your control actually. It's the model which readjusts and does it. So they are not hyperparameters. Only number of hidden layers and neurons are hyperparameters. This is where you could make some changes. So ultimately, when you do this feed forward and backward propagation, eventually what you realize is after so many cycles of feed forward and backward, you get a 0.9 probability for a circle. And that is when your model realizes that this is a circle. So is this making sense? Like now you got some clarity on what is a neural network in general. Now this function, right, this sigmoid function that you see, this function which I told you, this activation function can be very different. Like some people use sigmoid function, some people use ReLU. In ReLU, there is a very specific case also which they use. So if you just Google as activation functions in deep learning, you'll find so many. And what are these regularization techniques? I will show this to you when you read GAN also. But what is regularization? One regularization type is called L1, for example. In L1 regularization, what do? You make this weight infinitesimally small. For example, let's say make weight as let's say 0.000001, something like this. This may be L2 regularization. Okay. Now, suppose you want to do other kinds of regularization, then there is L1 regularization. What is regularization? Only to fix the issues that you are facing right now, right? So your model is not able to predict properly. So to fix that, what do? You do different kinds of regularization. Another regularization is L2, where you do make some weights as zero. Maybe I'm going into too much detail, but these are the different regulations. All of these you will have to maybe convey if there's a subject like deep learning or something. So likewise, there is one noise reduction, noise adjusting. There are so many different kinds of regularization models. Okay, so now let's look at the applications which you mostly know. It's the vision tasks or the speech recognition. Okay, this is the whole idea. Like under the hood, it is working like these black slides. Okay, exactly how this works. And you will realize it's mostly mathematical calculations that are happening reiteratively in a feed forward and backward method or mechanism. That's all. Okay, so far, any questions? I hope this is clear. Any questions on neural networks? Any doubts? Okay. Then I think I just put the definition of generative AI so that you are prepared for the next sessions. But yeah, Gen AI is basically which refers to algorithms that can create new content, including images, music, and text. Now, these models learn from existing data, enabling them to generate unique outputs and transform creative processes. Now, the only reason why I put generative AI definition here is so that you can relate this definition to the next topic, which is generative adversarial networks, GANs. Just focus on this one line. Just focus on this one line that these models learn from existing data, enabling them to generate unique outputs. Okay. And it can create new content. So just know that generative AI is very different only in the way that it is able to not just predict what is right or wrong, but also generate a lot of new content. And exactly when you learn GANs, you will come to know how new things are being generated with the concepts of generator and differentiator. Okay, discriminator, sorry. So you will come to know this. So now let's look at probably the last topic for today, and then we will have the hands-on understanding GANs. I repeat, any questions you can post in the chat regarding neural networks. So now let's look at GANs. Now, what is a generator and a discriminator? What is GAN in general, right? In a generative adversarial neural network, the generator is the one which creates, I repeat, synthetic data, right? Synthetic data from random noise inputs. And discriminator evaluates data to distinguish real from generated samples. So the best example that I can give you, or the best context that I can give you, is maybe let's say two teachers trying to simultaneously teach a student the same topic. This is exactly what is a generator and a discriminator, wherein generator is one algorithm kind of thing, discriminator is another algorithm kind of thing. They both are operating on the same data set and trying to improve each other's approach to make sure that the students learns best. Okay, now let's look at this in more detail. So what are GANs? It consists of two models, as I said, that compete with each other to analyze, capture, and copy the variations within a dataset. Right. So for an example, now see, uh, if somebody has to train, like you just understand the context here. If somebody has to build a machine learning model to identify fake nodes, do you think he will print lakhs of fake nodes in different ways to do that? No, right? So instead, your existing data set, if you could tamper, manipulate, modify, improvise, etc., to generate something slightly different, then it could act as a data set for you. Yes. So while the real database of data is here and it is feeding the real 100 rupee notes to the discriminator, there is a generator module which is feeding in fake notes to the discriminator. Now, what do you think is the job of the discriminator here? If you go by plain English, it is going to discriminate between what is real versus what is fake. Now, there are 2 points here. One point is that the discriminator will be having a higher loss if it is not able to discriminate, and the generator will be at a higher loss when it is not able to generate fake positions, fake nodes. So for an example, just to explain you again, suppose the generate, or maybe let's look at the process, then you understand it better. So what is a generator? Before that, a generator learns to create fake data by incorporating feedback from the discriminator. Okay, so there are some random noises or inputs and you feed that to a generator network, it generates some fake images. During generator, exactly, this is where I wanted to explain you what is happening at the generator training phase. You have real images as samples being fed to the discriminator, and you have fake samples being fed to the discriminator. Now there are two things here: generator loss and discriminator loss. Can you think when the generator will be at loss and when the discriminator will be at loss? I need this answer from you. Can you think, suppose the real image was fed to the discriminator and the fake image was fed to the discriminator, and the generator is at loss. That means what happened at the discriminator? Can you think? Anyone? See, it is as good as I generated a fake image from generator, fed it to the discriminator, but the discriminator disregarded that image, saying it is actually fake. That time the generator is at loss, right? The generator could not generate a very good fake image, and that is why discriminator was at par here. He won and he actually identified that the image was fake. This is the generator loss. So the generator will act and do back propagation only in the case of generator loss. That is why you see this like in a box. if you look at the discriminator where real images and fake images are being fed, this is the definition. But if you see here, what is happening? The discriminator will learn or do backpropagation only when it is at loss. That means it received a fake sample and it actually thought it is real. That time you have a discriminator at loss and generator is not at loss. So are you getting this? Should I maybe re-explain this again? It is basically two different models. One of them generates a fake image and other one has the real image. Discriminator takes both of them inside. If the discriminator is able to identify which image is fake, then generator is at loss. If it is not able to identify that the image is fake, then discriminator is at loss. Simple. This is what is being used in ChatGPT also these days, or any other content creation or content generation tool, that it is continuously creating new content based on existing data by tampering the existing data. Yes? Any questions so far? Is it not the same thing that is happening? Right? If you see here, the generator learns the distribution of data and is trained to increase the probability of the discriminator network to make mistakes. So here, this one is in focus. It takes some noise vector, creates more fake samples. And in the other one, you have real samples. So this is exactly how GANs work. Okay, you define the problem, you choose the architecture, train discriminator on the real data. Then, yeah, this order is very important here. First, you train the discriminator on the real data so that it knows what is real. Then you generate some fake data for the generator and train the discriminator on the fake data. Right? If something goes wrong, then you train the discriminator on the fake data, but otherwise also the discriminator continues to learn. Then in the end, you train the generator with the output of the discriminator. So if the discriminator is able to predict something correctly or wrongly, that input is being fed to the generator again so that it can even refine its generation of cosmetic outputs or fake outputs. That is all like how GANs work. So far, any questions? You can also, click on raise hand, or like you can raise your hand if you want me to repeat any topic. Anything you want me to repeat?
So,
Any
does
question?
the discriminator need training, or the training happens only on the generator?
The training happens on the discriminator and also on the generator. Both of them follow neural networks model of training, but the criteria on when they will be trained is different. So whoever from this image is at loss, that person will be trained. So if the discriminator loss is high, then discriminator needs to undergo backpropagation. And if the generator loss is high here, then the generator has to go through backpropagation learning.
Okay.
Does that answer your question?
Yes, yes.
Yeah, because the definition itself says it consists of two models that compete with each other. So if they are models, they both will have to be trained.
I think so. Whatever the images that have been generated by the generator, that will be fed as input for the discriminator, right?
Yes, yes. The fake image is fed to the discriminator. If it is able to identify that it is actually fake, then generator is at loss. It needs to relearn how to generate fake content. If not, then the discriminator is at loss. It needs to learn how to identify fake content.
Yeah.
Right?
Thank you.
Thank you for bringing that question now. Any other questions? Or then we are almost done with the foundations. We will head over to the hands-on now. Just a couple of applications of GANs. I think you may know it already. You could have thought of it very easily now that if you are generating more and more things, then it usually comes to, some or the other content creation, like generating cartoons. So all these fictional characters that you see, like maybe your, Pikachu and then Doraemon and all of that. So they are just imaginary things, right? So they are generated using GANs, as you would know, generating human faces. Now, let me tell you a very interesting thing. So I am not sure how many of you know. Um, there was this picture company called Images Bazaar. Yeah. So now, what was the model of this company of Images Bazaar is that suppose you see a lot of YouTube videos, right? You see a lot of content being created. You like if you open any article, like for example, if I open any article of mine itself. Now, suppose I wrote some article on metaverse. I took this picture, right? I took this picture. Similarly, if I pick on some more, let's say, wedding related articles, like maybe mine is not a very good example because I mostly write tech articles. If you want, you can go through them later also. But suppose I take a article on a wedding, right? See, not all, earlier what used to happen, all these people pertaining to weddings were actually real people. And the whole model of Images Bazaar was to create a set and bring in more actors, right? Male and female actors, and get wedding photo shoot done so that somebody can put it in their wedding albums or like in some YouTube videos, use them in some articles, in some interactive Instagram posts like that. Now, if you look at what is happening after GANs are into play, it is already generating human faces. So now, who is actually losing a job here? The actors, right? So now people don't want to create so many sets which are very costly and get all the fancy photographers who are very costly and then all the costumes and all the people and everything. Instead of getting that entire set created, now what's happening? Using GANs, based on existing images itself, people can generate new images of people who do not even exist, right? So this is where, maybe just a very classic example of how things change, right? How AI eats up, some occupation and all of that. But in the end, what you see is all the effort has gone away, right? Of onboarding photographers, onboarding actors, onboarding, people who have, clothes designers, the complete set, the shoot cameras and everything is gone. So this is one way, right? One use of GANs again of generating faces. Then bird with a black head, yellow body, and short beak, right? Exactly the prompts that you give in ChatGPT, text to image translation, right? So this is also an application of GAN. 3D object generation, right? I think drawing this for somebody would take like at least half an hour, but then within minutes you can generate this now, right? So on and so forth. There are a lot of things like this. But yeah, any questions again before we go to the hands-on?
I have one question. The output
Mhm.
of GANs uh, will always be fake, or is it like it can be real sometimes? For example, in this case, the faces of humans. Will it always
Mhm.
generate only the fake data that is not real, or there can be some real data also involved in that?
No, so the whole idea of GANs is to generate something which is unknown or does not exist. Because something which is already known, if you look at this thing, something which is already known is already present in your data set here. Something where you are running short of and where you think might come in the future, for that only you use generators. So the output of the entire GAN is usually an unknown thing. So in all the four applications also, if you see, these cartoon characters never existed earlier. These faces did not exist earlier. This bird may not exist because you may not always see a black and yellow color with a very long peak or something, or a short peak. Similarly, these images may or may not, this shape may or may not actually exist. So in most cases, it's an unknown output or a fake output that is generated. That's the very specific idea behind GANs.
Yeah, thank you.
Any other questions? Or else then we will just go to the hands-on for the next, let's say 40-45 minutes, and then post that we have the quiz. So yeah, let's start the hands-on. So I will, what I will help you do is, I will help you run a machine learning algorithm for text classification, just so that you get a gist of it. I have created, for now, I have created a Google Colab notebook, and I just want all of you to maybe, yeah, start referring this. So what I will do is I will post this notebook in the chat, and I will exactly request you to follow along. So suppose now this is a notebook that I have. What is this notebook about? This notebook is about classifying based on text whether a movie sentiment is positive or negative, something like that. Okay. So what I have done is I have used a Google Colab so that I can embed some explanation text also in the middle. And then you have some small code pieces in the middle. Then again, some explanations and then some code. Wherever necessary, I've written comments for you also. And you need not do any local installation. That is also a reason why I chose Google Colab. The moment you are signed in your browser with any of your email IDs, I think this should work for you. So what I will do is I will reiterate exactly what you are supposed to do. So let's say first thing I will do is I will open an incognito tab. You can do it in your browser tab and just copy the link that I shared in the chat and paste it in the browser. That would be the first step. So I request all of you to now follow along with me. What I'm doing right now, I'm just taking the link from the chat and pasting it in the browser.
It is saying I need access.
Exactly. So now this says you need access because I need to click on share and give access to all of you. Now, instead of giving access to all of you, I would do anyone with the link. And the moment I do this, you should be able to open it. Just refresh. Can you see it now?
Yeah, we got it.
Okay. Now for the people, right? For the people who do not have access to this so far, for you, what you have to do is, like, I mean, basically where you are getting this sign in page. So just simply sign in. That's all. Use your email ID and sign in. So let's say I am giving my email ID and then my password. The moment I sign in here, I should be able to see the same notebook, which some of you are already able to see, right? This notebook. So are we done with step one? Is everybody able to access? Anyone who's not able to access, just click on this raise button. Just raise your hand if you're not able to. Everybody is able to access this notebook. Then the next thing that we would do is I would request you to, let's say, maybe start using this alone, or what you can also do is you can click on file, download, and download the IPYNB file. I repeat, go to file in the notebook, go to file in the notebook, download, and click on download.ipynb. That means a Python notebook. Choose your downloads folder and then just save this. Are you able to follow, all of you? File. It's better all of you download so that you can upload it to your own drive, because right now it is in my workspace. So just click here and then save. Now, once you have saved, what you could do is, right now, you can always edit your own copies. So if you want to edit here, I'm okay with that. But if you want to do something else, like maybe upload a notebook, then click on upload and then browse that same Python file. Okay, maybe with a different name of your choice. So you can always do that also. That is up to you. If you are able to edit the same, nothing like it. Otherwise, you can run. So what is this? This is a notebook which has some basic code for you to try out an algorithm in machine learning using the TF library, okay, the TensorFlow library. Okay, so now what we will do is we will start running this application and seeing one by one like what is going on in this. So first thing that you should know is if you click on runtime in the Google Colab and click on change runtime, you can see if the code was, it automatically identified it is Python. But if you want it to be in R language or Julia language, you can do that. If you want CPU or GPU, like if you want GPUs or anything of that sort, you can choose, but that is for a very large data set. In your case, that is not needed. Okay. So now what we will do is we will just understand how this entire piece of code is working. And then simultaneously along with me, you can keep running the code as well and see the output. So is everybody able to follow? Do you have any questions? Perfect. Okay. So now see what this notebook contains. This notebook has basically what I have done here is I have tried to download the IMDb dataset. Okay, so dynamically it will download. It will not download. Please remember, it will not download in your local computer. It will download in the CPU or the cluster where this Google Colab is working. Okay. Now, for those of you who are still not like figuring out how it is working exactly the same way how Azure works, right? So what is happening? This is my computer, and from my computer, I am accessing this website. Where is this website hosted? This website is hosted, suppose for example, in North Central US. But I don't care. I have internet and my this entire website code is running here. Similarly, you have internet now and your entire code will run in some data center of Google, which I and you don't know. So let's not worry about the data center and all. Cloud is there to help us. Let's just worry about our code. Okay. So this notebook classifies movie reviews as positive or negative using the text of the review. This is an example of a binary classification. So I purposely used binary classification to simplify it. And eventually in the next sessions also, you will have some hands-on. So every day there'll be some hands-on, and we've tried to just simplify it as much as possible so that you can, do it on your own. So we use the IMDb dataset that contains 50,000 movie reviews, okay, from the Internet Movie Database. And we try to split like 25,000 reviews for testing and 25 for training. What, like some people ask, what is a good number or what is the good, let's say, uh, train versus test ratio, right? So according to me, if you ask, in most cases, having 70% train set and 50% test set would suffice. But in some cases, right, in some cases, it can even go to like 4:1. 4:1 basically means, how do I say? 60:40, right? Something like this. Sorry, 3:2. 66% and 33%, something like this, 3:2. So minimum of 30% test set you should have, otherwise your model will start overfitting. Okay, so what we have done here is, this was some explanation. The first thing is we are trying to set up the libraries. Now I request all of you to just click on this button. This is the run cell button. Just click on this button, and it, for the first time, it will take some time, like it is taking some time. It will revolve like this because it has to spin up the cluster in the background. Now just focus here. After a certain point, this will run. Yeah. So whenever you see this green tick, like I will just zoom this and show it to you again. Whenever here you see, whenever here you see a green tick with 14 seconds or something written, you will see an output here, right? So that means your code piece ran. And you will also see the RAM and disk space being consumed here, right? So 1.44 GBs of RAM is being consumed and 39 GBs of disk space out of 107 GBs is being used. So do you see different numbers here or you see the same number? All of you? My understanding is so far you should not see such a high RAM consumption. What is this value? Can you hover over and check and tell me what is the RAM consumption?
In my system, it is showing 1.54 GB RAM
Mhm.
and
Disk space?
39.08 GB for disk.
Yeah. So this happened because when you cloned, right? When you cloned my notebook from this place, it came along with the same cluster. So the data set was already downloaded, right? That is why in yours, you will already see the output, but it's better you run again. So what are we doing in first, let's say, what are we doing in the first section? We are
Excuse me.
importing some library.
Excuse me, Naman, can you just repeat what is that clone?
So basically, you took this link and you clicked right in your own Google account. The link that I shared in the chat,
Yeah,
you took the
yes,
same link and opened it with your Gmail. So what
exactly.
Google does smartly is it redirects you to the same cluster. So in the same cluster, because I ran it yesterday, so the data set is already downloaded. And because the data set is already downloaded, you see the disk space as 39 GB consumed out of 107 GBs. This may not be the case when you create this notebook from scratch. Then this may be 0 GB until you run the download IMDb dataset cell. Clear?
Okay, thank you.
Yeah. So now see what we were doing in section one, like I've divided it into very small chunks so we can categorize. This section only I am printing the different versions, right? So I'm checking what is the TensorFlow version, what is the eager mode version, what is the hub version, what is this hub? Hub is basically the place where all the TensorFlow libraries are present. So I'm just checking which version I am using. Like I'm using 0.16.1 hub version, 2.19.0 version of TensorFlow, like that. So once you run this, and you can always like later after the class, you can read the comments to understand it better. I'm anyway explaining. So once the setup is done for installation of libraries, the second thing is download the IMDb dataset. So to download the IMDb dataset, what I have done is, see, train data, comma test data. There are two variables in which I am downloading this, and how using the tfds dot as numpy train data and test data, I am downloading it. Okay. So what you do is you just click on this cell again, and then you will see it will download the complete data sets. Okay. And you can always track like 22 by 80 onwards. So next we will print this data set to see what is coming in the data set. Are you all able to run? Okay, so were you able to download the complete data set?
Yes.
Okay, nice. Now, see, what would really help here is, ma'am, or any other faculty, who's listening to this. See, suppose you you saw this line in your code, right? Like I will exactly tell you what makes a difference. You saw this line in your code. Now, I may not be able to explain it 100%. What you do is just open Google or ChatGPT and just type this one line, right? Just paste this one line. The moment you do this, right, it will immediately, like this is exactly what you will do next in the upcoming sessions, but I am already going to show this to you. So prompt engineering these days is like super critical. So maybe what you do is just paste this and then say explain each attribute of the above function. So like you want to know what is the usage of tfds.load. So just write a simple prompt. Right now you see it will explain you with an example on what's going on. Right. First thing is the first argument that you pass is name. So you are giving some name to your database, to your data set. Second is split, right? Which logical parts of the data set to return. So the data set that we are downloading already has a train and test split. So we are not splitting it. Instead, we are saying in the split, you pick train and test both kinds of data set. Second is batch size -1. See, I have tried my best to write every small or big thing in the comment. So feel free to read it from there. But otherwise also you can come to ChatGPT. So see, this one says using batch size -1 loads the entire data set in the memory. Right. So I am loading the entire data set in the memory in one go because it's not a very high consumption or like a very high volume data set. So we can do it. Now, as supervised, I'm passing one more thing. As supervised is equals to 2. So that means as supervised, why? Because I want to know, like I already know whether I want to predict the movie sentiment or not. So I am going to do some text classification. That means I have to specify that it is supervised because I have already want the labels to come in. See, as supervised is equals to 2 returns input comma label pairs directly, right? So similarly, converting to NumPy arrays for easier manipulation. And yeah, everywhere as NumPy, these two lines are basically converting them into arrays for easier manipulation. So
Yeah, Naman.
yeah, sorry. Am I audible
Um,
now?
yeah, you're audible.
I did not realize when I dropped off. Can you help me
Oh,
with where I lost?
you were speaking about that as supervised true.
Okay, okay, I got it. I got it. Thank you, ma'am. So we will continue from here. So what happens here is now we pass as supervised is equals to true because we know the
Naman,
goal of our.
your screen is not shared.
Sorry, let me share it. Let me know once it's visible.
Yeah, now it's visible.
Hmm. Okay.
Yes,
So
it's visible.
perfect. The reason why we pass as supervised is equals to true is because we want to download this entire data set along with the labels. Why labels? Because we know we have to predict the overall sentiment. So the output variable here is known. And if you go back to the theory, I already told you when your output variable is known, it is supervised learning, right? So once the download of the data set has happened, let us go to the next step. We want to explore the data. So far, is everybody able to download the data set?
Yeah.
Okay, perfect. Now to explore the data set, I've written a very simple print statement. Okay. Now the moment you write a print statement, let's see, it says the training entries are 25,000 and test entries are 25,000 because I just printed the length. This is like very basic Python. Okay. Now what I'm doing, first 10 rows of the train example I am running. Okay. So how I run, like there are multiple ways. What I do is I hit like this shift plus enter. But what you can do is you can just run like this. So when you run like this, let us see. I will copy this and maybe I will try to beautify this a bit so that you are able to read it properly. Let me minimize this a bit more. Okay, so see what is happening here is if you see each of the comma separated values here, there are basically first 10 lines that I have printed. So you will see the first 10 records. Okay, so just look for commas. Wherever there is a comma, I am just trying to break it down. Like this, you see 10, and in the end, you see d type is equals to object, which means data type is object. So ultimately, it is one big chunk of this complete B information, and then the other part of it after comma is d type is equals to object. What is this? The first 10 data sets or the first 10 rows in your sheet. And see, you can see I've been known to fall asleep during films, but this is usually due to a combination of this. So people have written superb, somebody has written, uh, precisely good, bad, whatever. Then there is a lot of, like, somebody mentioned Japanese prison camps. Like that, you see a lot of information, right? Somebody has mentioned sci-fi films, etc. Now, this is the data set that we just printed in cell number 4. Okay, cell number 5, sorry. After that, if you go down from the train labels also, I have just printed array of 0, 0, 0, 1, 1, 1. So these are basically the positive or negative outputs, right? Because we have some known outputs as well so that our model can learn well, right? So that is why in the train labels, we have 0, 0, 0, 1, 1, 1. That means third, fourth, and fifth, fourth, fifth, and sixth row is actually useful in the Excel, right? Which has some result. Similarly, now, or let's say which has a positive result and these ones have negative result. So till up till 6, if we are done, then now let's start trying to build the model. Okay, now because you already just finished neural networks, so you will be easily able to relate. So shall we start with building the model now?
Yes, we can go ahead.
Okay. So what we do now is to build the model, we have to ask some questions, right? This is exactly, all the engineering brains, they come up together and they first understand how to represent the text, how many layers in the model, and how many hidden units, right? So as I said, these are the hyperparameters which you decide, right? So in this example, the input consists of sentences. The labels to predict are either 0 or 1. 0 means negative, 1 means positive. One way to represent the text is to convert sentences into embedding vectors, right? So what you saw here, each of them can be a vector value, right? So for this example, we have used TensorFlow Hub, okay? And there are two models that we have used, normalization, like one is this one and one is this one. Ultimately, what we are doing here is we are giving we are choosing an online open source model with hub layer is equals to hub.keras layer. And in that, we are passing the name of the model, the input shape, and the data type, which is a string, and trainable is equals to true. It is all common sense, right? Data type, we have to tell it is a string. Whether train or yes or no, yes, true. Input shape is basically array, right? It is an array. And then model. Which model? This model. So right now we are just trying to build a model. If you run this, you will see that it will give you a vector, right? So some training examples like how it is going to train. See, all the text that you saw got converted into a vector like this of arrays. Getting it? So what is this? If you could imagine, this is nothing but your input layer which got transformed. Are you able to relate? In the neural networks, what did we do? We had this, we converted it into individual pixels and then gave these individual pixels here. Do you remember? Same thing we are doing here. The image was converted into pixels. Now this data we converted it into an array vector. Is this relatable? Are you able to relate? Right? Then later what we do like some simple, let's say model building activities, wherein in the model we add the hub layer and we give them some density. Okay, we are clearly specifying the activation function as ReLU here. Okay, so you can see everything that we talked about, we are doing it in hands-on now. Okay, so activation function we are passing ReLU. Now, if you see no activation on last layer here, so logics, that basically means in the last layer we are not applying the activation function. Now, there is no specific reason for that. It's just that the model works properly there. So we are doing it that way. Okay. So now if you see the layers are stacked sequentially, this is basically some explanation about the hidden units and what is the loss function. Okay. So eventually what you see here is we do a model dot compile. This is where we are converting the entire code. Okay, you can keep running like one by one, so you will come to know. So here what is happening in the model.compile, we are giving an optimizer called Adam. Why an optimizer is needed? An optimizer is needed exactly for such problems here. So when there is an error towards the end and the output is not working, that time we need to apply some backpropagation. And for backpropagation, only activation function alone will not be important. You will have to make slight tweaks in your database, in your data as well. So that means remove some noise from the data. So all the tampering of the data, for that we use this optimization. And Adam is just an optimizer, like it's a very famous optimizer only for uh, such kind of data. Okay. So see, as it says, adaptive learning rate, for adaptive learning rate, Adam is one of the widely used optimizers. Then the next is creating a validation set, right? So 1 minute. Yeah, so we were here. Now, after we have identified the, let's start from the beginning and revise what we did so far. We first set up the libraries. Then we downloaded the IMDb dataset. After downloading, we just tried printing the length or volume of data. Then we started doing model building. For model building, we specified the input shape and the data type and everything and converted it into a vector. After converting it into a vector, let me expand the cells. We also gave it an activation function called ReLU, an open source model which is of this link, and then we added some hidden units and some loss function optimizer. Okay, so we gave 0.0 as a threshold for now, and then from here onwards our training set has been curated. Now we are going for a validation set. So for the validation set, see what we are doing. We are taking a partial amount, right? So validation set is very important to tune the model. As you know, validation set is nothing but your test set. So to detect overfitting before touching the test data, we keep 10,000 examples aside, right? So what we are doing is 0 to 10,000 we are just ignoring for now. Okay, and the remaining ones we are considering. Okay, now this is the line which is training your model. Okay, so we are setting a variable history and storing all of the training outputs into model.fit. Okay, so once we do model.fit, the accuracy for every you can say the accuracy for every record keeps on getting printed, like 0.9512, 0.9590, like that. You will see the accuracy keeps on getting. What is epoch? Epoch is nothing but time. So with time, what is happening, right? So we are plotting the accuracy with time, so that repeatedly when back propagation and feed forward is happening, with passing of time, what is happening? So that we will analyze below. See, when we evaluate the model, we see the we when we print the results, this is basically giving you an estimate of how the model may perform in the unseen data, right? See, because for the test set the output is not known. So if you test your model on the test set data for which the model has not been trained, then only you can know in real world if somebody writes another review how your model will predict, right? Will it predict properly or not? Getting it? So here you see what is happening here is the different accuracy levels are mentioned. So a loss of 0.79, which is very low, but an accuracy of 78%, right? So on and so forth. Now, what to visualize this whole thing better and to explain you the concept of overfitting, I purposefully plotted some graph as well. So I will show it to you, the graph. Yeah. After your model evaluation is complete, I just created a graph of accuracy and loss over time. So when you run this, what you will see is with time, okay, just carefully observe what is happening is with time, okay, your training loss is continuously increasing, but with time, your training loss is continuously decreasing, okay, with time. That means the more you train your model, the training loss will keep coming down, right? Because training loss is basically what? The data which could not be trained. So that is ultimately coming down, down, down. Epoch is basically time. So let's say 0 second, 5 second, 10 second, 15 second, like that. What happened? So what happened? Initially, the training loss was very high. It came to almost zero. But the validation loss kept on increasing after a certain threshold. So it came down for some time, but there is a point after that it started increasing. Now, can somebody justify what happened here? Or maybe I will show you the next graph. This was training and validation loss. Now this is train and validation accuracy. Now you compare these two graphs and tell me in the validation accuracy, what happened with time? Okay. With time, what became constant is your validation accuracy. And what kept on increasing to us to some extent is your training accuracy, right? So my only question to you is what is happening here? See, this you may expect, right? Like with time, your accuracy is increasing, like is becoming constant for test set. It is not increasing, but for validation, it is 100%. So that basically means what? When you were now, like, just listen carefully. When you trained your model, with time, what happened? Your model was getting trained better, better, and better. That is why your loss came down and your accuracy went high with time. So training part is complete. The loss came down with time and the accuracy of training increased over time. This is pretty much clear and common sense. But the problem that happens, okay, the problem that happens is with the validation or the test set. In test set, what happened? When we started, right? When we started, we were getting very good accuracy. But after some point, the accuracy became constant and the loss started increasing. See, validation losses started increasing at the same time, but at the same time, this became constant accuracy. Why? This is a classic case of overfitting, right? So see, the same thing is written here. Notice that the training loss decreases with each epoch and the training accuracy increases. This is expected when we use a gradient descent. So this is okay. This isn't the case for validation loss and accuracy. They seem to peak after about 20 epochs, something like here, 20 epochs. This is an example of overfitting. That means your model, I repeat, your model started learning something which it was not supposed to learn. Okay, that is why it started learning some additional things because of which the accuracy which was increasing after a certain point, it stopped increasing. The accuracy stopped increasing because it started making more and more mistakes because of over learning or let's say overfitting. So how to, like somebody might question, how to identify if my model is overfitting? The best way to identify when your model is overfitting is when you have high train accuracy but low test accuracy. Okay, that means see, when it goes to training accuracy, your model was like very good. You see this dot dot dot, it has gone to 100%. So training may you are getting 100% accuracy. But when it comes to validation accuracy, it is only 85%, right? That means your model is overfitting. So for that, there are those techniques which I explained you here. They were called, I think, L1, L2. There are so many regularization techniques. So on, like sometimes you make the weight zero, then this one, then sometimes you do hyperparameter tuning, like you increase the number of hidden layers, decrease the layers, then likewise change the activation function. So there are many ways. All of this come under regularization. Even after regularization, if you are not able to reduce the overfitting of your model, then you go for optimization techniques in deep learning. Okay, so then there are techniques like, not sure like if you've heard of it, there are techniques like pooling. Okay, so there are different types of pooling in that. There is a maximum pooling. Like, have you heard of it? Maximum pooling and then average pooling. Those kind of things start happening. Okay, so these are optimization techniques, but before optimization techniques, you should apply all of these. These are what? Regularization methods. So ultimately, the goal is to make your model more and more optimized in the end. That is the whole goal of your uh, you know notebook or like Google Colab here. So now any questions? You can anywhere like run all of this and see the outputs, and please read through the text. Like they are like very simple terms. I have written everything along with the comments everywhere, so you can just read and understand it pretty easily. Now any questions you have, any doubts? I did not go for a very high intensive hands-on or something because it's the first day, so I want to make sure like everybody is comfortable first.
So speakers, if you have any clarity that is needed, you can just, sorry, the participants, so they could actually raise your hand or you could unmute the mic and ask the query. Oh, so Naman, do we have hands-on session on GAN kind of coding?
Uh, right now, so we did not plan on that. But the thing is, this automatic, I did not plan an explicit GAN one, but since this one has neural networks, so let's say the foundation of GAN is present here. If the hands-on on GAN specifically, but that also requires very high compute. So for Google Colab, it will be little difficult. It will require some local installations.
Fine.
Yeah, but this covers the supervised, unsupervised approach, the basic training of a AI algorithm, and also how to identify train and test set ratio versus how to interpret the outputs, and also how to feed in the right activation function for your neural network. So all of this is covered initially in this hands-on. Like it was like
Yes.
one master example to do
Yeah,
all of
yeah.
this.
Yes, yes.
Okay, so we
Okay.
have 18 minutes. So now let's come to the final part, which is a quiz. So what I would request all of you is, let's say this is 4:42. By 4:55, let us all plan to finish this quiz. And the simplest thing that you will have to do is, you just have to open your phone and scan this QR code and start answering the questions. Please know that because we are also considering the leaderboard here, whoever gets the maximum right, etc., towards the end also they get something. So we will not allow any submissions after 4:55. There are 20 questions and around 12 minutes to answer them. Please scan this QR code and submit before 4:55. You can open your Google Lens like Google, open Google in your mobile phone and then click on the Google Lens icon and then do it. Or what I can also do is I can share the link in the chat. So from your desktop also you can do it. If you are comfortable doing this, you can do it this way. So just in case, like few of you are not available near the system or not able to take up the quiz right now, you can take it up at a later point also. It's fine. But make sure you finish it by today. And yeah, I mean, honestly, so let's see. And meanwhile, if you have any questions, you can ask. We have one last part left after this. Then we can wind up the session. You will also find the link of this quiz in the WhatsApp group as well, and also in the Teams chat.
So, Naman, I have also shared the link in the WhatsApp group. So, I think I can keep it open till 6 o'clock at least.
Sure, sure. I will open it till 6 o'clock.
Yeah.
So let's wait till 4:55 for the people who are already doing it. And in the last 5 minutes, I have just one last thing and then we can continue.
I think parallel you can just continue, no problem. Let them
Okay.
keep filling. Yeah.
So yeah, once you are done with the quiz, I think, yeah, it's time for us to conclude the session. So if you want to like reach out to me for anything anyway, fifth day, I will again be there. You can always take my contact from Netra ma'am and anybody from BIT. You can visit this website swipegen.in for all the courses, etc. If you want to upskill yourself or students from your colleges want to do the same thing, we have this WhatsApp number. And yeah, I would just like to thank all of you for being a very patient listener. And I really enjoyed doing this because I think it was a very good topic. I just wanted to simplify it as much as possible so that it always gets into everybody's head that okay, like it's not really big thing or something. It's just the way of explaining things. So thank you so much for all the questions and also answering those questions. I'm really happy about it. So just one last request from our side. Please scan this QR code and it will take barely, let's say a minute or less than that to scan this QR code and submit the feedback only for today's session. This activity we will have every day, and you will have to scan this QR code shown by your instructor on all the following days, and you have to submit the feedback for the session. So please do it. Make sure you add any comments if you liked it or you did not like it. It was like fast, slow, whatever, anything you would like to improve in the further sessions since this is day one. We really appreciate your feedback. So yeah, request all of you to just scan this QR code.
It's not shared, Naman.
Is the screen not shared?
No.
Okay, let me do it again. So yeah, you can always scan this QR code. So we offer, trainings for a lot of colleges in Bangalore already. I'm not sure of the participants, and some of you we might already be doing it. So the thing is, if you want any strategic tie-ups with our company for trainings and upskilling students for placements, etc., also you can reach out on this number or visit the SwipeGen website. So please submit your feedback. And then I have one last announcement, just in case you like reading. And I think when ma'am was introducing me in the beginning of the session, she told the book that I'm writing. So the book actually got published already, so it's out there in the market. We've received like very good response from the industry about this book. I wrote this book for anybody who's a beginner to cloud. So the first four chapters of this book are completely for anybody across any industry as a beginner. So after the fourth chapter, from 5 to the remaining chapters, it's focused on Azure API management. The whole idea was like somebody who's a very novice or very new to cloud can learn and practically do all of this. So it is a hands-on, completely hands-on guide. You will have screenshots of how to do things in Azure and everything. So you can go to Amazon and order this. This is also one way how I could be of help to you in case we don't interact in the future. So I thought, if you are really interested and you learn by reading, then probably this book might help you. So once again, thank you so much, all of you, for joining today's session. It was a wonderful session, and thank you, Netra ma'am, Suma ma'am, everybody for helping us out.
Yeah, thank you for the insightful session. It was too informative, Naman. And also, we will truly appreciate you for your effort and the preparation, whatever you have put forward to keep the contents more informative. And also would like to congratulate on the publishing your book. So, can you just share that QR code again for the feedback? So that can I share that in the WhatsApp group as well? Yeah,
Yes, yes. So I shared it with you and also in the
yeah,
Teams
this
chat.
is the link, right? Yeah,
Yes, this is the link for the feedback.
yeah. Okay, thank you, Naman. So thank you, participants. So we will close the session for today. So maybe tomorrow, so at same 2 o'clock, we will be just initiating the second session. So thank you for attending. So patiently listening to all the content. So thank you, Naman, once again.
Thank you so much, ma'am. Thank you, everyone. Have a great day ahead and see you guys tomorrow.
Thank you, Naman.
ಎರಡು ಲಿಂಕ್ ಇದೆ ಕಳಿಸ್ಲಾ